And welcome to the Daily Space Weather Show. It looks like there might be some intelligent life on the planet as you've found the channel. So we'll just bring you the world's most comprehensive space weather content and most detailed solar imagery in the known universe. So let's blow that up a little bigger. There you go. And yeah, it's been quiet for the past 24 hours. There was a stealth CME impact exactly as forecasted. It showed up around midday universal time today. There'll be another one showing up tomorrow and another one showing up on the 19th, and we'll tell you all about why. First, some more spectacular imagery from Solar Dynamics Observatory. So there's a great equatorial zoom in 304 angstroms, the ionized helium wavelength, and that sunspot there that is south of the Earth scale is by far the most likely place to see a large solar flare. It still has the kind of magnetic fields that you would expect to see a large flare from. So there you have it. What that's not close enough, you want to see that a little bit more closely. All right, I guess we could probably accommodate you there. But first, this massive filament. So there are a number of massive filaments here that have been rising in the east. And of course, CMEs persist, as we say all the time on the channel. Remember, folks, you don't need sunspots or even solar flares to see coronal mass ejections. They happen all the time, despite no sunspots or flares. So, of course, we've started monitoring these things are closer to solar minimum, and we still realize that we're able to forecast coronal mass ejections. So, in any case, there's 171 angstroms, the same quite massive filament there. Something like 100,000 kilometers in length. I mean, it doesn't even fully fit on the frame there. But one of the many things that we show on the channel. So, yeah, features. And we'll talk about the solar cycle progress and so forth here in just a moment. And before we get to any more types of imagery, let's thank all of our viewers for tuning into the Smash News Network, least busted name in news. If you enjoy the content, don't forget to press the like button. If you're new to the channel, don't forget to press subscribe. Otherwise, how would you get the world's most comprehensive space weather content delivered directly to your YouTube subscription feed? I guess you wouldn't. Also, visit the links, support the channel, etc. Look at the pathetic number of views on our videos. I mean, you'd think there'd be a market with the emphasis on private space flight. So yeah, that's YouTube for you, folks. That's YouTube. So barely 4 days until summertime, so that's something to consider. Here is our SDO 171 angstroms along with the colorized magnetogram. Again, eyes on that sunspot. It's just moving into the exactly Earth-facing zone there in the southern hemisphere. So that sunspot is something that we'll be keeping an eye on. And when I say eye on, well, the pun is intentional. 10.7 centimeter radial flux is now at 171 solar flux units. 171 is the radial flux number. That is a proportional data set to sunspot number. As you can see there, radial flux depicted by the black line, sunspot number depicted by the red line. That's the past year from solon.info/solar. Sunspot number here hovering around 150 at the moment. Also, I would note that if you look at the lowest sunspot numbers, you can see this upward trend, an indication that we're getting higher lows, because we're expecting solar maximum to show up sometime around October of this year. So that's what you would expect to see, higher highs and higher lows. Allow me to reduce the, there we go, that's a little better. That looks a little bit better. So, Space Weather Enthusiast Dashboard forecasting a little bit of geomagnetic unrest tomorrow night, Monday night into Tuesday. So that's probably the other CME that we forecasted, because it doesn't look like a coronal hole high-speed stream on the models. So here is that's the Enlil spiral from NOAA that doesn't load. Of course, many of the features of the space weather modeling framework, the Space Weather Prediction Center, were down, so that one's not coming up. Now, ESA's Enlil spiral is up. Of course, it's different servers, the European Space Agency. But there's the forecast from ESA, and it looks like they indeed did forecast. So that's our forecast lining up with European Space Agency. They just don't have the other two CMEs modeled that are on the way, as it does look like they're expecting a coronal hole high-speed stream to show up here really late on the 21st. Okay. Also, the geosphere, the geospace magnetosphere movies are not playing either. I'll just press refresh. You'll see it does not load. So we'll have to skip that section for today also. No magnetosphere movies. KP index is at 2.66, which is geomagnetically calm conditions. Now, we do have some missing data here from both the ACE and the Discover, which is unfortunate. However, it does look like the CME arrived just about when we said, by midday today. So, again, another one coming tomorrow. It'll be minor also. And another one coming on the 19th, late in the day on the 19th. So, it'll be here by late day the 19th. We'll show you that CME. It was another stealthy one. So, another great example of how if you immerse yourself in the data and have a clue what you're looking at, you'll be able to do quite accurate forecasts. It's just a matter of doing the work. If you are lazy and you don't understand the way the data ties together, you'll be useless at space weather. And if you're doing space weather videos, we sincerely hope that you're able to forecast in any way. Current conditions at ACE are about 5.25 protons per cubic centimeter. Solar wind velocity here quite nominal at about 415 kilometers a second. The Discover's got a little bit less missing data there, and it's got a little bit higher readings. Solar wind density there close to 15 protons per cubic centimeter. Solar wind velocity here a little higher as well, 443 kilometers per second. And this is sometime after the CME impact. It looks like right in there. CME impact there showing up as forecasted by noontime today on June 16th. There are goes magnetometers, as most aspects of the NOAA Space Weather Prediction Center are now back up. And Earth is in a South Pole magnetic sector here. So you can see that South Pole magnetic sector there building up, and now it's shrinking down again. So as early as tomorrow's space weather video, we may be back in a North Pole magnetic sector. North Pole magnetic sector is depicted here in green, South Pole depicted in red, which brings us to our line of sight field plot. Pretty well-defined coronal hole in the northern hemisphere there. That's of South Pole orientation. The one rotating toward the western limb, that is of North Pole orientation. Here is our coronal hole line of sight plot. And that brings us to coronal holes from SDO. There you go. There's the SDO imagery. Next, we'll get to sunspots. That north polar coronal hole there is not likely to have any geo-effective properties. In other words, it's not likely to send Earth a high-speed solar wind. So sunspot number here just over 150. Sunspot number is 152, I'll say. 152 is a sunspot number. And just a quick note about the comparison of solar cycles. You can see that the green line there, that's solar cycle 25. It's a much stronger cycle than solar cycle 24 at this point. It may exceed solar cycle 16. Many people are expecting a higher peak actually after solar maximum, which again we're expecting in October. So we may see this solar cycle surpass cycle 16, which is the pink line. At the moment, it is above cycle 16, but you know it took a while to get back over there. So we'll have to see what happens there. But solar cycle 25 is certainly a stronger cycle than cycle 24, cycle 12, cycle 14. So there you go. There are the similar amplitude solar cycles comparison. Will it exceed solar cycle 13? Maybe in the tail end. But yeah, there you go. Next is our flare probability monitor and scoreboard. The likelihood of large flares really isn't all that high. However, if we do see a large solar flare, it's by far most likely to come from sunspot 3712. So that's the south centrally based one there. And yeah, it's got the type of magnetic fields that you could expect to see large solar flares. You can see the flare probability monitor there is showing as high as 61%. So more likely to see an X-class flare than not based on what's going on. And we'll show you the magnetic shear associated with that here coming up next. So here is the SDO continuum. That is a 24-hour video at 30 frames per second. And we'll bring you in real nice and close to that sunspot 3712. It remains the T-mass, most active sunspot, and moving forward, we're expecting it to remain the most active sunspot. By far the most likely place for a large solar flare. And when you look at the magnetogram, you'll see a lot of black and white, well-defined regions close to each other. So here's the continuum once again. This is similar to what you would see if you looked at the sun through a solar filter, a basic solar filter. And here is the magnetogram. It uses polarized light, the Lehman effect, to figure out the magnetic fields. So again, as you can see, there are multiple places there that are what we would call deltas. It is a beta gamma delta class sunspot group. And next we'll take a look at energetic particles and solar flares. So the proton flux here is back to baseline levels. We're not expecting any upticks in this. Maybe if you have a very large solar flare, but even then it's kind of unlikely due to its proximity to the center disk. The most likely places to produce proton events are around the western limb. Proton flux now back at baseline levels. So no M-class intensifications for the past 24 hours. Over the last 48, we only had an M1.3. So yeah, it's been quiet, but maybe it's a ticking time bomb, folks. Ticking time bomb. Although there's really no reason to be frightened of solar flares. The X-rays don't even reach ground level, and it's when people say, "Ooh, there's a big solar flare risk," it's not a risk to really anybody. The flare itself really doesn't equate to any sort of a risk, especially for people on the ground. Anyway, here's our solar system forecast before we get to CMEs. Oh wait, we gotta show flares. So there's a quick look at 94 angstroms, sunspot 3712. It is quite likely indeed to produce an X-class event, which is no reason to be frightened of it, because space weather isn't scary. And folks, just a little reminder that these videos are rather pedestrian. All right, I realized over a decade ago that forecasting earthly weather is far too easy, and now I'm at the point where forecasting space weather is also far too easy. And you know, you gotta keep moving on to greater and greater challenges, folks. So just a little hint about how to keep yourself fresh. It works like this: evolve or die. All right, you've got two choices: evolve or die. So please pick the former and avoid the latter, if you don't mind. So here's our solar system forecast before we move into CMEs. This is where things are today as Earth swings past Ceres, which is in retrograde, which is why it's surrounded in purple there on that image. It's really far away. I mean, it's farther away than Mars's orbit, which makes it like in the outer portion of the solar system. So, I don't know. Somebody's going to say, oh no, Ceres is going to do a thing to Earth. Anyway, here's a star chart. This is what's going on over our heads in Lehigh Valley, PA. If you want to check out your own, skyandtelescope.org has a great site for this. I like their star charts. You can like move the point of, you can move your like vision around here, so you can get an idea of what the constellation will look like from the ground. It's really good. Mars is setting on our western horizon here over Lehigh Valley, PA. And before we get to... So this depicts a star getting a little bit too close to a black hole and then getting spaghettified. This is our apod.nasa.gov astronomy photo of the day. apod.nasa.gov. This is showing the perspective of from the accretion disk that the stellar matter forms. Some of it gets ejected out into interstellar space, but some of it gets formed into an accretion disk around the massive radio source known as a black hole. So there you can see the jets forming as it becomes active. It also emits neutrinos. If you want to read the articles about it that are linked on apod.nasa.gov, feel free. That's what it might look like if you're in the accretion disk, as there could be lensing effects and so forth. Keep in mind, quite a bit of this is theoretical. It is an artist's rendition of a black hole spaghettifying a star. So moving on to CMEs, and there was another stealthy one early this morning. So you'll see it kind of coming out there of the southwest. It was quite close to the center of the solar disk, which means some of the ejecta will strike Earth. So that's the CME arriving later in the day, sometime after midday universal time on the 19th. Another stealthy CME on the way to Earth. So let's bring this back. We're going to show it to you here. So right there, you can see that ejecta coming out of the west and the south. That is an Earth-directed CME once again, and we'll show you its origin point here in a minute. I'd like to show you more data from Stereo A to sort of solidify that for you. Unfortunately, Stereo A's data is too low of resolution to have caught that, so that the ejecta is a little too diffuse here for Stereo A to see it. Stereo A is located out there where that red dot is located. So there's the view from Stereo A, and unfortunately, it doesn't really show up on this. So we do have Mercury and Venus there on the imagery as well. And let's cut to our custom coronagraphs. So right there, you can see that ejecta coming out of the west and south. It looks like another one has happened just in the past couple of hours, so that could be a double whammy. Also, keep in mind there is a coronal hole high-speed stream likely on the way. It'll be a short-lived one, but that can create what we call a co-interactive region, where the coronal hole high-speed stream can catch up to or get caught up to by a coronal mass ejection, in which case they're able to do things like amplify each other, de-amplify each other, affect each other's trajectory and things, because keep in mind they have their own magnetic fields typically. So, you know, there aren't a lot of forces at work as a CME or a coronal hole high-speed stream material just kind of flows through space. It's largely inertial, and so, you know, tiny forces can have large effects on that ejecta, that solar plasma, as it makes its way toward Earth. So here's a little closer view, and you're going to see right where my pointer is right there, you're going to see a little brightening right there. So that was the source of that CME. And like I said, it is on the way. I'm going to arrive by midday on the 19th. So another one to come tomorrow. And yeah, stealthy CMEs. What can you say? If you immerse yourself in the data, folks, you might get answers that are not asked for. So there you go. There you have it. And let's do bonus features here and close this thing out to get it onto your screens. Filaments are next. Look at the massive plasma filament that's risen over there in the east. Dag, that is one bulky filament. So you see that dark area? That is an absorption feature that is blocking the emission of the hydrogen alpha 6,562.8 angstroms wavelength. And yeah, that is one of the larger filaments we've ever covered on the channel, dating back right around 6 years at this point. That is an absolutely massive filament. And of course, if you look at it here from the grayscale imagery, you can see prominences as well, like that huge prominence that we showed you up there in the northeast. So, filaments, filaments, filaments. Still plenty of them on the Earth side of the disk. Still a very high likelihood of X-class solar flares. Here are the past couple of hours in the GOES 16 SUVI, 304 angstroms wavelength. Crown prominence is up there as well at the northern polar region, and a small one at the south. So here come bonus features, starting out with satellite charging hazards. We ain't got none. It's smooth sailing for satellites. Electron flux remains surprisingly low. It could have a chance to rebound before more CMEs strike tomorrow, but it's sort of doubtful. And NOAA agrees that electron flux levels will remain kind of low. Now, that's measured at the F layer of the ionosphere using radiography. There's where the F layer is located at 300 kilometers of altitude. And here is the F layer. This depicts megahertz, millions of vibrations per second, as diffuse gas vibrates very rapidly. Of course, the denser the gas is, the harder it is to vibrate it. So, but the F layer is space. 300 kilometers of altitude is way up there. And that is what's going on at the upper portion of the bridge between Earth and space. The F layer of the ionosphere. Okay? Here's the anomalygram. We show it daily on the channel. It does give us some insight into what's going on with space weather, and we're seeing quite a bit of low-frequency anomaly here. Hey, there's been some space weather impacts as forecasted, so it's not really that surprising. Also, like we said, it didn't really cause any major geomagnetic storms. It was diffuse plasma. It was stealthy, but there you have it. Facts. The ionosphere agrees. The ionosphere agrees with all of the facts stated regularly on the channel. Pardon us if they're inconvenient facts. Here's our total electron content and maximum usable radio frequency. And it's nothing to write home about. No major anomalies going on there in either of those data sets. We are seeing some anomalies in the anomaly calculation. I don't know what's up with that. It's been doing that for days. But hey, what can you do? You get the data you get, and you make guesses about the rest of the stuff, right? So here's our latest. Looks like a sunspot's going to form up here in the northeast, that's for sure. And as far as down here, not so much going on. Let's take a close-up of sunspot 3712. So some great examples of deltas in there, both in these leading umbral groups as well as the trailing umbral groups. That is what makes them so likely to produce large solar flares. And just a quick reminder that solar flares are actually predictable. Yeah, believe it or not, solar flares are predictable. Anyway, we'll close out with our house favorite wavelength, 171 angstroms. Keep an eye on filaments. And make sure you follow us over on X if you'd like to name filaments after your favorite friends and or foes. That massive plasma filament rising down there in the southeast is certainly a candidate for getting names. Anyway, we'll see you soon here at the Smash News Network, least busted name in news. Congratulations on realizing the channel exists. We're frankly surprised that you have with the state of affairs on social media. And we'll see you next time. In the meantime, I've been your host, Dan, a.k.a. Smash-a-Mash, headed back to the bunker. And in the meantime, may that solar wind be at your back. Whoa.